All right, so I've fixed this formula. It was a parentheses problem. It always is. I never can get it right the first time. But if you look at this formula, I hope some of y'all, especially finance majors and accounting majors, see if you can let this sink in because, wow, this is powerful stuff. This is something I thought about while riding a bike one day, and I thought, wow, this is great. I have not seen it taught like this in any classes. I've had a couple of students say they've seen it in graduate level, but I think it's really, really good to understand. It really frustrates me with students that plug things in the calculators and get answers that are obviously wrong and it doesn't bother them. And you got to get to the point where you have to understand what's going on. What is the calculation? What's the math behind this? So if you get a ridiculously bad answer, you know, wow, I plugged in a number wrong, I hit something wrong. But know what the calculators are doing. Financial calculators, I see students just plugging stuff in and whatever comes out, that's what they write down. Know what the calculator is doing. The calculator is not there to do the thinking for you. It's to save you time, but you need to know what the calculator is doing. And so here's the formula that I put together. I took D9. D9 is the $30 cash flow. So let me see if I can rewrite it with actual numbers. So I took $30 and divide it by 0.0036. That's my discount rate. Remember the discount rate, 0.0036. I divide by 2 because it pays coupons twice a year. All right, the value of this is the formula that tells you if you take a cash flow and divide it by the discount rate, it's telling you the value of that cash flow if you received it for all of eternity. And you need to adjust it. So if it's a monthly cash flow, you'd have to divide it by the interest rate divided by 12, just like we did with some of the exercises in Excel applications 2 and 3. Here, because it's twice a year, we divide by 2. So that's the present value of a cash flow received for all of eternity. We're actually going to use that formula when we value stocks. Plus, well, we're going to also get $1,000. So we have to put the $1,000 in there. We get the $1,000 in 5 years. But we're not going to receive $30 for all of eternity. So we have to subtract that out. But if we just subtract it out, we're just going to end up with $1,000, right? Because here's the value of $30 for all of eternity, and here subtract $30 for all of eternity. But the key is this $1,000 and the $30 for all of eternity, we need to add the $1,000 in 5 years and subtract out $30 for all of eternity in 5 years. So in that case, we take it 1 plus 0.0036, again, divided by 2, and to raise it to the 10th, it's 5-year bond, but remember we're getting coupons twice a year, so it's 10 payments. So the N here is the number of payments, just like what you did in Excel applications 2 and 3. And so when you do all of that, you can see that the resulting calculation is exactly the same price, $12.7923. So what's interesting about this formula? Well, let's change this formula, and let's say we're going to get $1. Our discount rate's 5%, and there's no $1,000. So we're just going to get $1 for 5 years. All right, let's make it really simple. So I'm going to do the same formula again. 1 divided by 0.05. It's just once a year, so we don't have to divide by 2 or anything. So there's a value of $1 received for all of eternity if we discount it at 5%. And then we're going to subtract $1 divided by 0.05. But we're going to discount that at 1 plus 0.05 raised to the 5th. So essentially we're taking the value of $1 for all of eternity minus the value of $1 for all of eternity, but 5 years out. And when we get that, we'll get the value of $1 received once a year for the next 5 years if our discount rate's 5%. When you do that formula, you will get, when you do all of that, you get 4.3295. I hope you remember something from Excel applications 2 and 3, but we had this present value interest factor of an annuity, and here's the formula: 1 minus 1 divided by 1 plus I raised to the n divided by I. And look, when I do that, what I get? 1 minus 1 divided by 1 plus 0.05 raised to the 5th divided by 0.05. I get the exact same answer. So if you think about it, what is the present value interest factor of an annuity doing? It's taking $1 for all of eternity divided by the discount rate, minus $1 for all of eternity divided by the discount rate, but discounted out 5 years. So that factor, that's the source of that factor. And you can use the present value interest factor annuity problem. You can use that formula. Here you can simplify it, and it simplifies. You'll have to do the math yourself, but it simplifies to this formula. That's essentially what I'm doing here. Exactly that formula, with one exception, is I'm adding in the principal that I receive at the end, the $100 at the end. So I don't know if all that made sense, but boy, it's a way that if you don't have a financial calculator, but you need to calculate the value of a bond, this formula, it might seem a lot more complicated than it really is. If you think about what you're doing, it's really not that complicated. It's just taking the present value of a dollar amount for all of eternity, plus $1,000 minus that infinite cash flow, but discounted for whatever time period and interest rate you're using. So anyway, just thought that'd be curious for you to see that. On the exam, and on your Excel applications, it's extremely important. I must see this table. And the reason I require this table is I want to make sure students understand exactly what the value of the bond is. That it's the present value of these cash flows. I want you to see it physically. If you want to have this formula in there as well, and you can build this in, you see exactly how I did it. You can build it in so you can double check your work. That is fine as well. I have no trouble with that at all. So there's the value of a bond, of a treasury bond. So now what we want to do is a corporate, and then we'll do, after we do the corporate, we'll do the Excel application example. So let's do the corporate bond. So here I got to give you a little bit more information. So let's say this is a 20-year corporate bond issued 10 years ago. Let's say it is rated BBB today, but was rated A+ 10 years ago at issuance. So when they issued this bond, remember initial issuance, we talked about that in a previous class, that initial time they go out to the market and they borrow money, that goes through investment banks, over-the-counter type of transaction. After that, the trading happens between investors, but that initial issuance, that cash goes through the corporation. And let's say the face again is $1,000, just like we've been doing. We'll always do it as $1,000. Let's say the coupon, well, it was 10 years ago. Boy, 2010, who knows what it is. Let's say the coupon was 5%. I don't know what the coupon for A+ bond was back then. So now we got to do the yield. So let me give you some numbers. Let's take some treasury yields. These are current yields. I should say that, current yields. And let's say the 10-year treasury. I'm going to use bogus numbers because the current rates are so low. So let's just pretend like it's 1%. And let's say the 20-year treasury, the current rate, let's say, is 1.5%. All right, and let's do some spreads. So again, we'll do 10-year and we'll do 20-year, and we're going to do A+ bonds and BBB bonds. So let's say BBB bond yields, well, AAA bonds, let's say it's 50 and BBB is 230. And for 20 years, let's say it's 65 and BBB is 270. All right, so there's our spreads. So the question is, what is our discount rate? So if you remember from Excel application 6, again, boy, I'm hoping you're not forgetting stuff you got before, because this stuff will come back again and again and again in your college classes. But remember that the discount rate is the risk-free rate plus the spread. So the first question is, what is the risk-free rate? All right, well, it's a 20-year corporate bond, so you might say, well, it's a 20-year corporate bond, maybe it's a 20-year treasury. But you want to ignore that. You want to ignore that it's a 20-year bond. All you care about is how much time is left. Well, if it's a 20-year bond issued 10 years ago, there's 10 years left. If it was a 20-year bond issued 15 years ago, there'd be 5 years left. All right, so it's really, for all intents and purposes, it is a 10-year bond. That's all that's left. So you want to make sure your risk-free rate is for the time that's left. And then we do the spread. Remember, the spread, you have to divide by 10,000. So the spread is going to be, well, what? Well, we don't care about the fact that it was A plus when it was issued. That doesn't matter. What we care about is what is its rating today. Today it's rated triple B, and it has 10 years left. So I'll probably do something like this on the final. I don't think it's in your Excel application. So here's one place. I'll try to make sure when we do the team question that I do it just like this so you can see how I might try to trick you a little bit. So the spread is 230. So remember, for the spread, you take 230 basis points and divide by 10,000. And so my discount rate, my KD, my discount rate, we use KD, remember, on Excel application 6. You just add the two together. And then the next thing you have to do is the effective yield. Don't forget the effective yield. The effective yield, you take 1 plus the discount rate divided by 2, raise it a second, and then minus 1. We always do that with the corporate or treasury. If this were a CD where you get interest monthly, then you would divide by 12 and raise it to the 12th. But here, because cash coupons are paid twice a year, we divide by 2 and raise it to the second. You always do that every single time. And we do that, we notice you get an effective yield that's slightly higher. It would always be higher, but slightly higher than your effective yield. Oops. All right. And so down here, we'll do time, cash flow, just like we did before, discount factor, and discounted cash flow. Remember, your first time is half a year. You'll take half a year plus 0.5. We need to go down 20 lines. So we want our last one to be year 10. So we go down 20 lines, but we have from 0.5 to 10. It's going to be hard for me to show you all of this, so hopefully it's not going to get too small so you can't see it. I'll hide some rows here in a little bit so you can see everything. Then our cash flow, remember, our cash flow is the face amount times the coupon divided by 2. And then below that, you just want to reference that and copy it down. Except for the very, very last time you add the face amount back for the bond. So every time you do a bond, you'll have the same number until the very end, and the very end you'll have that number plus $1,000. All right, so then we need to do the discount factor. To do the discount factor, we take 1 divided by 1 plus the effective yield. Make sure you do the effective yield. Close parentheses, raise the time. Make sure on the effective yield that you lock it in with dollar signs. Go out 4 decimal places, copy that down. That gives you your discount factor. And in your discounted cash flow, you just take the cash flow times the discount factor. Copy that down. So now we have the price. And remember, the price is nothing more than the sum of those discounted cash flows. That's the definition. And again, this is a premium bond. Why? Because the coupon's 5%, but our discount rate's only 3.3%. Let me see if I can do it as a formula. Remember, I never get it right the first time, but we'll try. So we'll take $25 divided by the discount rate, not the effective rate, but the discount rate. When we hit divide by 2, we're essentially doing that effective yield. So there's the value of $25 for all of eternity. We'll add to that $1,000 minus the coupon divided by our effective rate divided by 2. We'll take all of that and divide it by 1 plus our discount rate divided by 2 raised to the what? Anybody thought of the number yet? It's 10 years, but we're dividing by 2, so we have to raise it to the 20. Hopefully y'all saw that. And then drum roll. Looks like I got it right that time. So that's the way you can check your math and make sure you have it exactly right. So there's that formula. You don't have to use this on the exam. I just really like it because it shows that you know what your calculator is doing. That just makes me feel really good. So there's a corporate bond. The key here is understanding what kind of bond is it. If it was a 20-year bond issued 18 years ago, it's a 2-year bond. If it's a 30-year bond issued 15 years ago, it's a 15-year bond. It's a 10-year bond issued 7 years ago, it's a 3-year bond. So you just take the bond, what the term of the bond is minus how many years ago it was issued, and that difference tells you what kind of bond it is. That will determine your discount rate. It will determine your spread, both the year and the rating. All we care about is the current rating. All we care about is how many years are left. You then take that risk-free rate plus the spread. Remember, the spread is in basis points, so you have to divide by 10,000. Always divide by 10,000. That never changes. You add those two together to get your discount rate. The effective yield is you want to take in consideration these pays twice a year, so you want to compound that coupon one extra time a year, so you get a slightly higher effective yield. You then show the time in 6-month increments, so 0.51, 1.52. Your cash flow is your face times the coupon divided by 2. Your discount factor is just like we've been doing, and it's 1 divided by 1 plus the rate raised the time. Your discounted cash flow, you just multiply across. Your price is just the sum of all those, and then there's a formula that gets that to you that's very similar. Remember, it's identical to the present value interest factor or annuity formula, with the exception of we're adding in the $1,000 for the maturity value. And we're using 25 as our cash flow rather than 1 that's in that formula. So hopefully that's making sense and you feel a little more comfortable with this. But what we'll do next session is we'll work out the Excel application. I'll do the first one, and boy, this one should be easy. Once you get the first one set up, the second one should be a piece of cake. And then I'll make sure, if we look at the Excel applications, it's what I haven't thrown in there is what the bond was rated when I issued. I do have a 10-year bond maturing in 5 years, so be real careful. I kind of get tricky. Here it doesn't matter because it's going to be 5 either way, but if I say a 10-year bond maturing in 5 years, then it's a 5-year bond. Let's practice this. We got about a minute here. So what kind of bond is it? If it's 10 years, maturing in 5 years, it's a 5-year bond. If it's a 10-year bond maturing in 2 years, it's a 2-year bond. If it's a 10-year bond issued 8 years ago, that is a 2-year bond. All right, so sometimes I say, when was it issued? It was issued 8 years ago. That way, that makes it a 2-year bond. If I say it's a 10-year bond maturing in 2 years, that makes it a 2-year bond. All right, so just want to be really clear on this. Here, it's a little tricky because I say 10-year bond maturing in 5 years. So would have worked either way. Here, I got a 15-year bond maturing in 10 years. So what is this bond? Think about it. Is it a 5-year bond or a 10-year bond? I say maturing in 10 years, so it's a 10-year bond. If I said it's a 15-year bond issued 5 years ago, then you would say it's also a 5-year bond, but I would have worded it differently. Not to be tricky. Oh, there's actually 3 problems. So slightly different. So you do have 3 problems. I thought you just had 2. So what we'll do next class, next session, same class, is we'll do this Exxon bond, and then that'll set you up to do the other 2 problems, and then you'll have Excel application 10 ready to go.